Hello, I'm Ardra. Today I'm going to discuss about a new topic in physical chemistry. Now we are going to discuss about surface chemistry. In today's class, we are mainly going to discuss about adsorption. The contents of today's class include physical adsorption and chemical adsorption, the differences and similarities between these physical and chemical adsorption. And we are also going to discuss about the factors that affecting adsorption. There are several factors. We are going to discuss it all of it by one. First, what is surface chemistry? Surface chemistry is that branch of chemistry which deals with the study of phenomena that occur at the surface or interface. Surface is a plane that separates two media. If when two media are separated by a thin plane, that plane is called the surface. And surface chemistry is the branch of chemistry that deals with the phenomena that occur at the surface of two media. Adsorption. First is adsorption. Adsorption is a term that occurs at the surface that separates two media. The phenomenon of attracting and retaining the molecules of substances on the surface of a liquid or a solid, resulting into a higher concentration of molecules on the surface, is called adsorption. As a result of adsorption, there is a decrease of surface energy. Adsorption is the phenomenon of retaining molecules or substances at the surface of a particular other substance. That is, there will be an accumulation of a specific substance only on the surface of a liquid. On contrary of adsorption, we know that in absorption there will be uniform distribution of another substance on a specific other substance, but in adsorption, there will only be accumulation of substance or increased concentration of other substance in the surface of the liquid. As a result of adsorption, there is a decrease in the surface energy. We know that the substance will only get adsorbed on the surface. So, when accumulation of substances increases, there will be a decrease in the surface energy of a specific substance. What is desorption? The process of removal of an adsorbed substance from a surface on which it is adsorbed is called desorption. It is the reverse of adsorption and can be brought about by heating or by reducing the pressure. So, the reverse of the process of adsorption is called a desorption. When adsorption is the accumulation of substance, the removal of the adsorbed substance from from this surface, it get adsorbed is called desorption. And desorption, the process can be increased by increasing the temperature or by decreasing of pressure. We will discuss about the factors in the later on this class. What is adsorbent? This substance on which the this substance on the surface of which adsorption occurs is known as adsorbent. The substance on which on which a certain other substance will get adsorbed is called adsorbent. And what is adsorbate? The substance that get adsorbed on the solid surface due to intermolecular attraction are called adsorbate. The substance that gets adsorbed on a specific surface is called adsorbate. So we can conclude that an adsorbent is a substance on which a particular other substance get adsorbed, and adsorbate is the substance that get adsorbed on a surface. Next, we are going to discuss about the difference between adsorption and absorption. In absorption, it is the phenomenon in which the particle of gas or liquid gets uniformly distributed throughout the body of the solid. When a liquid or a gas is getting absorbed on a solid surface, in absorption, there will be a uniform distribution of the liquid or a gas throughout the solid. The concentration is same throughout the material. Therefore, it is a bulk phenomenon. The absorption occurs in bulk, and the concentration of the absorbed substance will be uniform throughout the substance that is absorbing the other substance. And the absorption occurs at a uniform rate. The absorption will be same in all over the body of the substance that is absorbing the substance. When we discuss about adsorption, it is the phenomenon of higher concentration of gas or liquid on the surface than in the bulk of the solid. So in adsorption, there will only be an accumulation or higher concentration of the gas or liquid that is get adsorbed on the solid phase. That is, solid is absorbing the gas or the liquid. So there will be a higher concentration of gas or liquid only on the surface of the solid. The concentration on the surface of the adsorbent is different from that in the bulk. Therefore, it is a surface phenomenon. Even though there will be a slight absorption in the in the solid, there will be a higher concentration of the adsorbate only on the surface of the adsorbent. Adsorption is rapid in the beginning and its rate slowly decreases. We know that surface energy decreases when adsorption occurs. On a certain value, adsorption stops. So it will be, adsorption is rapid in the beginning and its rate slowly decreases. There is a figure that shows adsorption and absorption here. In adsorption, there will be accumulation of substances only on the surface, and in absorption, there will be uniform distribution of substance throughout the substance that is absorbing the substance. Next, we are going to discuss about the thermodynamics of adsorption. Adsorption is a exothermic process. Exothermic process, that is, it releases energy when adsorption occurs. Therefore, delta H of adsorption is always negative. When a gas is adsorbed, the entropy of the gas decreases. So a gas can move freely in the space. When these gas get adsorbed on a solid surface, it is rearranged only on the surface of the adsorbent. So its energy, so its disorder decreases. So delta S is negative for adsorption, and it is a exothermic process. So delta H is also negative for adsorption process. The adsorption is thus accompanied by decrease in enthalpy as well as entropy of the system. For a process to be spontaneous, requirement is that delta H must be negative. So for adsorption process, delta H is negative, delta S is also negative. For a specific process to be spontaneous in nature, delta G should always be negative. So in order to acquire delta G negative, on the basis of the equation, delta G is equal to delta H minus T delta S. From the equation, we can see that delta G is the difference of delta enthalpy, delta H and the T product of temperature and delta S. Delta G can be negative if delta H has sufficiently high negative value, as delta S minus delta Ts is positive. The delta G, we have to acquire delta G as a negative value. In order to delta G to be a negative value, delta H should be highly negative, or the product, that is minus T delta S, should be positive. That is, if this positive, if the T delta is positive, the negative sign gives more negative value. Thus, in an adsorption process which is spontaneous, delta S is negative and delta G is sufficiently negative, and a combination of these two factors, delta G is negative. For an adsorption process, we know that delta H will be negative and delta S will also be negative. In order for that process to be spontaneous, delta H should be highly negative. That will compensate the product of T delta S, that is delta S also be negative. So the T delta S will be negative. When the negative sign add to the negative sign of this equation, it will all get positive. So in order for a adsorption process to be spontaneous, delta H should be highly negative. Delta H become less and less negative as adsorption proceeds further and further. Ultimately, delta H become equal to T delta S, and delta G becomes 0. This is the state at which equilibrium is obtained. When adsorption occurs further and further, there will be the delta H value will become less and less negative. So it will get equal to the T delta S value, and the delta G will become 0. We know that when delta G is equal to 0, it is the equilibrium condition. That is the state in which the adsorption process is in equilibrium. Enthalpy of adsorption. What is enthalpy of adsorption? We are going to discuss. It is the amount of heat released when 1 mole of an adsorbate gas adsorbed on a particular adsorbent at a adsorption equilibrium It depends upon the nature of both the adsorbate as well as the adsorbent. Enthalpy of adsorption is the amount of heat that is released when 1 mole of an adsorbate gas. The enthalpy of adsorption is the amount of heat released when 1 mole of an adsorbate gas is adsorbed on a particular adsorbent at equilibrium attained. When equilibrium is obtained, the amount of heat released by 1 mole of an adsorbate gas on a particular adsorbent is the enthalpy of adsorption. And the enthalpy of adsorption will depend upon the enthalpy of adsorption between an adsorbent and adsorbate will depend upon the nature of both the adsorbent and adsorbate. Next, we are going to discuss about difference between the physical adsorption and the chemical adsorption. In physical adsorption occurs when there is a when the attraction between the molecules of adsorbent and adsorbate is by physical forces, that is by van der Waals forces, and chemical adsorption is the process in which the adsorption occurs or the attraction between the adsorbent and adsorbate is with chemical forces. So physical adsorption, the forces between the adsorbate molecule and the adsorbent are weak van der Waals forces. When the force between the adsorbent and adsorbate molecule is weak van der Waals forces, it is called physical adsorption. And in chemical adsorption, the forces between the adsorbate molecules and adsorbent are strong chemical forces. The forces between the adsorbent and the adsorbate will be strong chemical forces. In physical adsorption, low heat of adsorption of the order of 20 to 40 kilojoule. The enthalpy of adsorption in physical adsorption will be 20 to 40 kilojoules, and in the case of chemical adsorption, there will be a high heat of adsorption that is in the order of 200 to 400 kilojoule per mole. The physical adsorption usually occurs at a low temperature and it decreases with increasing pressure. So, when the temperature is low, physical adsorption will occur more rapidly. When there is an increased temperature, the adsorbed substances will tend to escape from the surface. So, the physical adsorption will decreases with the increased temperature. But in chemical adsorption, it is found out that it occurs at a high temperature because it is a chemical reaction. Higher activation energy should be required. So, it occurs at high temperature. Physical adsorption is reversible. That is, the adsorbent can be separated from the adsorbate, but in chemical adsorption, it is irreversible. So the adsorbate cannot be separated from the adsorbent substance. The extent of in physical adsorption, the extent of adsorption depend upon the ease of liquefaction of the gas. That is, the adsorption will depend upon the nature of the adsorbate or adsorbate. That is the gas. Easily liquefiable gas will get easily adsorbed on the surface of the adsorbent. So, in chemical adsorption, there is no correlation between the extent of adsorption and the ease of liquefaction of gas. In chemical adsorption, the adsorption merely occurs by the media of chemical forces. There is no correlation between the extent of adsorption and ease of liquefaction of gas. In physical adsorption, it is less specific in nature. All gases are adsorbed on the surface of the solid to some extent. But in case of chemical adsorption, it is highly specific in nature and occurs only when there is a bond formation between the adsorbent and adsorbate molecule. In nature, there will a lot of easily liquefiable gas. So, all these gases that is easily liquefiable will get adsorbed on the surface of the adsorbent. That is the case of physical adsorption. But chemical adsorption is highly specific in nature. The adsorbent and adsorbate that is compatible to each other will only get adsorbed on the surface of the adsorbent. In physical adsorption, it will form multimolecular layers. That is, when a surface, when the surface there will be an adsorption occur, a layer will be formed, and on the top of that, another layer will form. So, the physical adsorption is it occurs by multi layers, but in chemical adsorption, it forms only mono layers. The extent of adsorption, that is X by M. X is the number of moles of adsorbate that get adsorbed on the surface of the adsorbent, and M is the mass of the m is the mass of the adsorbent present. The extent of adsorption increases with the pressure. In both cases, the extent of adsorption will increases with the pressure. When more pressure is applied, that the process of adsorption will increases. Next, application of adsorption. The adsorption is used in adsorption chromatography like column chromatography, gas chromatography is widely used in chemical analysis. For chemical analysis, we use column chromatography, gas chromatography, etc. The a substance that will be when we do chemical reaction, there will be a collection of substances we occurred in a beaker. So we have to separate their specific substance. It was only possible by column chromatography, gas chromatography, etc. Each substance will have a specific attraction toward the adsorbent surface, so it will undergo this specific adsorption, and substances will be retained on the surface of the adsorbent at a particular rate, so the surface substances can be separated from them. Gas masks function because easily liquefiable poisonous gases like chlorine, SO2, sulfur dioxide, sulfur trioxide, etc. get absorbed on the activated charcoal in preference to non-poisonous gases, even if these are present in very small amount in nature. When we dig in the mines, etc., when we go deep, there will be an accumulation of the poisonous gases. So in the gas masks, there will be activated charcoal. These poisonous gases are easily liquefiable, so it can be easily absorbed absorbed by the activated charcoal. So it will save the person that is undergoing mining, etc. A mixture of noble gases can be separated by using coconut charcoal by maintaining different temperature. We will study about the Devas process, etc., that is used to separate the noble gases present. So it is done by the noble gases are separated by using coconut charcoal by maintaining the different temperature. At a specific temperature, one noble gas will escape, and another temperature another noble gas will escape, and it will be collected. This process is also used to separate the mixture of noble gases. Next, adsorption of gases on solid. We are going to discuss about the factors that depend upon the extent of adsorption of a gas on the solid surface. The first is the nature of the gas, that is the nature of adsorbate. Easily liquefiable gases such as HCl, NH3, chlorine, etc. are adsorbed more than permanent gases like H2, N2, and O2. The hydrogen chloride, ammonia, and chlorine are highly more liquefiable gas. They have a high critical temperature, so it can get easily liquefied on the surface of the adsorbent. But the hydrogen, nitrogen, oxygen, etc., which is not easily liquefiable because they have a low critical temperature. It cannot be easily liquefied liquefied by maintaining the temperature. So easily liquefiable gases like hydrogen chloride, ammonia, chlorine, etc. will get easily adsorbed on the surface of the adsorbent. Here we can see that sulfur dioxide will have a critical temperature of 330 Kelvin, methane will have 190 Kelvin, and hydrogen will have 33 Kelvin. So sulfur dioxide can be easily liquefiable because it have a high critical temperature. But on the other hand, hydrogen will have a low critical temperature, so it can easily escape into atmosphere. It cannot be easily liquefiable, so it is difficult to absorb the hydrogen gas on a specific adsorbent. Next factor is nature of adsorbent. First we discussed about the nature of adsorbate. Next we will discuss about the nature of adsorbent. The extent of adsorption of a gas depend upon the nature of adsorbent. Activated charcoal, metal oxides, and clay can adsorb gases which are easily liquefied. Activated charcoal and metal oxides like silica gel, aluminum oxide, and clay can adsorb gases which are easily liquefiable. But the non easily liquefiable gases like hydrogen, nitrogen, oxygen can only be adsorbed by finely divided transition metals like nickel and cobalt. The traditional method, traditional adsorbents that we use in used in household, etc., are activated charcoal, metal oxide, and clay. It can only absorb easily liquefiable gas, but specific materials like finely divided transition metals like nickel, cobalt is required for the adsorption of non-easily liquefiable gases like hydrogen, nitrogen, oxygen, etc. Next is the effect of temperature. Third factor is effect of the temperature. Mostly the process of adsorption is exothermic. We discussed the process of adsorption is exothermic. There will be a release of heat energy, and the reverse process desorption is endothermic. We can think that we will know that if a process is exothermic, the reverse process of that process will be uh, endothermic. That is adsorption. For adsorption, the reverse process is desorption. So desorption process is endothermic. If the above equilibrium is obtained to increase in the temperature, then according to Le Chatelier principle, with increase in temperature, desorption will be favored. That is, when there is an equilibrium exists between the absorption and desorption process, if temperature is increased, the system try to use up the heat. So use up the heat, it is only possible by desorption, increasing the desorption process. That is the endothermic process. In the endothermic process, there will be a using up of heat. So when there is an equilibrium with the absorption and desorption, and if we increase the temperature, the system will try to use up the energy. That is, desorption process will be more favored. Physical adsorption increases continuously with increase in temperature, whereas in chemical adsorption increases initially, then shows a maximum in the curve, and then it decreases continuously. Here there is two graph, that x by m, that is accumulation of the adsorbate on the surface of the adsorbent, which is drawn against the temperature. So in the physical adsorption, there will be a continuous decrease in the adsorption or in the accumulation of materials when there is an increase in the temperature. But in chemical adsorption, we can see that there will be an increase in the accumulation of substances on the surface of adsorbent when we increase the temperature, but it will decrease when a specified temperature is reached. After reaching a specified temperature, there will be a decrease in the adsorption process. First there will be an increase, later on there will be a decrease in the adsorption process. What is activated adsorption? It is in case of chemical adsorption, the initial increase in the chemisorption with increase in the temperature is because of activation energy required. We saw that in the graph there will be an increase. First there will be an increase in the adsorption process in the chemical adsorption. This is because of the increase in the temperature gives energy to the adsorbent, and an activation energy is required for the adsorbent to function. It is provided by the increased temperature. So there will be an initial increase in the chemisorption with the increase in the temperature. This is why chemisorption is also called activated adsorption. So chemisorption is also called activated absorption because the adsorbent needs an energy to function in a proper way. So it will get activated when the temperature is increases. So chemisorption is also called the chemical activated adsorption. And adsorption isobar, a graph that is between the degree of adsorption, that is x by m, and the temperature at a constant pressure of adsorbate gas is known as adsorption isobar. So at a constant pressure, the graph that is drawn at a constant pressure, we will call it as an isobar. So if a graph is drawn between the degree of adsorption, that is x by m, and the temperature at a constant pressure, it is called the adsorption isobar. There will be no change in the pressure. It is if the proper condition is provided that it is only being constant pressure. So the graph that is drawn between x by m and the temperature is called adsorption isobar. Next, we are going to discuss about the fourth factor, that is pressure. The extent of adsorption of a gas per unit mass of an adsorbent depend upon the pressure of the gas. That is x by m. The degree of adsorption will always depend upon the pressure of the gas. Pressure of the gas that is provided. That is the pressure of adsorbate, the variation of the extent of adsorption expressed as x by m and the pressure. There is a graph drawn here. Here we can see that a graph is drawn between x by m and pressure, and there is variation. If the pressure is increased, there will be a low pressure, and if the pressure increases, there will be a slight increase in the adsorption of the adsorbate on the adsorbent. The graph between the amount of adsorption and the gas pressure keeping the temperature constant is called adsorption isotherm. We know that all graph that drawn at a constant temperature is called the isotherm. So if we draw a graph between the degree of adsorption, that is x by m, and against the pressure, it is called the adsorption isotherm. It will be drawn at a constant temperature. We have to study about the character of about the dependence of pressure on the adsorption. So we will take the temperature as a constant. So the graph drawn between x by m and pressure is called adsorption isotherm. Next, we are going to discuss about the extent of adsorption. So next is the extent of adsorption increases with the pressure and becomes maximum corresponding to the pressure is called the equilibrium pressure. We can see that there will be an increase in the degree of adsorption when pressure is increased, and it will get to a maximum value at a specified pressure. This pressure at which the adsorption is maximum is called equilibrium pressure. It is noted by P as P and subscript S is given. It is called the equilibrium pressure. Since adsorption is a reversible process, the desorption also takes place simultaneously. We know that adsorption is a reversible process. Continuous desorption will also occur at the so it is a reversible process, and desorption will also be occur if we reduce the pressure. At this pressure, that is equilibrium pressure, the amount of gas adsorbed becomes equal to the amount of gas dissolved. That is, at equilibrium, the amount of gas adsorbed will be equal to the amount of gas dissolved. Thank you. That is the end of this class. Thank you.